Hello students, and welcome back to the fourth video of this lesson. In this video we're going to be looking at another practice problem connecting the function f of x with its derivative f prime of x. So let's get right into it. Here we go. So here we're given an equation f prime of x equals x times 2 minus x times x plus 3. We want to determine when do we have intervals increasing and decreasing and then justify our answers. Well, in order to do this, we want to get the critical values. And since we're given f prime already, we're going to figure out the critical values when the derivative equals 0. And when is that going to be? Well, that's going to be when x equals 0, x equals 2, and when x equals negative 3. So remember, we're going to make our handy dandy sign chart for f prime of x. Hopefully I made this large enough. All right, and so I'm going to put in negative 3, I'm going to put in 0, and I'm going to put in 2. So we've got all these intervals, and we're going to substitute in values up above into our original function for f prime. Okay, so value less than negative 3, I'm going to use x equals negative 4. And let's see what happens to our sign. So negative 4, that's going to be negative. And then up there where it says 2 minus negative 4, that's going to be 2 plus 4, so that's going to be positive. And negative 4 plus 3, that's going to be negative. And so overall, I get a positive answer. And positive, we want to remember, means we're increasing. Now let's look in between the interval negative 3 and 0. I'm going to use negative 1 in this case. X equals negative 1. And all right, so negative 1, that's going to be negative. And then 2 minus negative 1, that's going to be 2 plus 1, which is going to be positive. And negative 1 plus 3, that's going to be positive. So overall, this entire part is going to become negative. And negative means we are decreasing. All right, so my next x value in between 0 and 2, I'm going to use x equals positive 1. And so positive 1, that's going to be positive. And then 2 minus 1, that's going to be positive. And then 1 plus 3, that's going to be positive. So all these positives mean I get a positive answer, positive value out no matter what. And that's going to be increasing. And then now let's use a value greater than 2. I'm just going to use 3 in this case. X equals positive 3. So 3, that's going to be positive. And then 2 minus 3, that's going to be a negative. And then 3 plus 3, that's positive. So overall, this positive times a negative times a positive, I'm going to get a negative. So that means we're decreasing. So that's not enough. That we need to use calculus reasoning here. And in order to do that, we have to write out words. So we want to say f of x is increasing when f prime of x is positive, when f prime of x is greater than 0. And when is that happening? Well, we've already written arrows out where the function's increasing, so that's happening in between negative infinity up to the critical value, which was negative 3. And then at another point, union in between 0 and 2. So I'm going to write down those values. And then on the flip side, f of x is decreasing when f prime of x is negative, when it's less than 0. And so I already put the arrows down, but where are we negative? Well, that's happening in between negative 3 and 0, and union in between 2 all the way to infinity. So those two answers are going to be where we're having increasing and decreasing. And we have analysis. So we have analysis using our handy dandy sign chart, but we still need to say f of x is increasing when f prime is greater than 0. We also have to say it's decreasing when f prime is less than 0. We need to make those statements. That sign chart isn't enough without writing that. So moving on from here, what values of x does the graph reach a relative minimum? Well, we want to have a reason. So we'll say f of x has a relative minimum when f prime of x changes from, so minimum, so decreasing to increasing, so that's going to be negative to positive. So from negative to positive. And when is that happening? That happens at x equals 0 in this case. That's the only part where it changes from negative to positive, and you can see that in our handy dandy sign chart. And along with that, we want to see where we have a relative maximum. So f of x has a relative max when f prime of x, so when it's going from increasing to decreasing, so from positive to negative, so when f prime of x changes from positive to negative. And where is that happening? Well, that's happening in two spots, and go look at your sign chart to see that. That's happening at x equals -3 and at x equals +2. So now we want to say, okay, if f of 4 equals -1, what is the equation of the tangent line? So f of 4 is -1. So we have our point of tangency given to us. That's going to be 4, -1. Now we want to find our slope of the tangent line. So I'm going to substitute that into my original function, f prime. So f prime of 4 is going to be 4 times 2 minus 4 times 4 plus 3. And let's see, 2 minus 4, that's -2. 4 plus 3 is 7. So -2 times 7 is 14. And 14 times 4, 28, 56. So -56. Okay, so that's my slope. And that's why when you get weird slopes or big numbers or small numbers or pi or e in this case, or in some cases, that's why it's important just to throw it into that point slope form. So using point slope form, that's going to say y plus 1 equals -56 times x minus 4. And that's the slope of the tangent line. And what I would encourage you to do, well, you can't really check it against a function f of x at this point. So that's just going to be it. You could find the original function using integration, but we're not there yet. If you're interested in learning a little bit more about integration, you can go ahead and reach out to me on that. But we do have one problem left in this video, so let's look at that one. And in this one, we want to approximate the value of f of 4.1. So what I'm going to do is substitute that into my equation up above for the slope of the tangent line, since 4.1 is super close to 4. So I'm going to get y plus 1 equals -56 times 4.1 minus 4. So y plus 1 equals -56 times 0.1. And I get y plus 1 equals -5.6. And I subtract 1, so I'm going to get y equals -6.6. So what are we saying here? We're saying f of 4.1 is approximately -6.6. So we now need to say why this is a good approximation. So this is a good approximation because 4.1 is a close value to 4, which we just found up above. So therefore, the y value of f of 4.1 will be close to that tangent line that we used. Okay, students, thanks for hanging in there in this video. We do have one more video left, one more example left in this lesson, and that's actually going to be the final example in this entire module before you have a quiz and an exam. So stay with it, one more video. If you do need any help, make sure you guys do reach out to me. I'm Mr. Hernandez, and this is Mr. Hernandez Teaches.